Here's an example of two-step IEB geners that are creating the backup generations in this case with a +1 and a +2. Notice that in the first step, we take our data and we create a generation data set +1. In the second step, we take that generation that we just created, the +1, and now we are creating a +2 generation. So we are creating two brand new generation data sets from this two-step proc. Let's take a look at how this is going to work when we try to create various data sets. And we'll take a look at it from the perspective of what it looks like when the job ends, as well as the various iterations of what we can do when the job itself is running and creating these generations and what they look like when they have been created. In looking at this example of our IEB gener, notice that what we are doing now is reading the input data set and we're creating a generation data set as output. So since this represents the base and we are creating a new generation, we are using a +1 relative number, and then we specify all of the other values that would be associated with creating a new data set. So the thing that the generation data set designation gives us is the ability to generate a unique name without having to change the base name. So in this case here, for example, when I run this now, what I'm going to end up with is that I'm going to end up with a data set now that's been created that has that unique generation number. So in this case here, what I can do then is that I can take a look, see if the job is running. We can see that the job completed. We got a return code 0. So we'll go take a look at what this looks like now in our data set list. So in this case here, I'm going to find this, and you can see now that we have our base defined, and you can see the volume serial number on the right just has question marks because it's not a data set, it's simply a catalog entry. And then underneath that, we can see generation 1 has been created. Now, since we have a limit of 3, then what's going to happen is that if I were to run this job multiple times, we would create a generation 2, then a generation 3, and when we create a generation 4, then generation 1 would be deleted. So let's go take a look and see if we actually do this, what's going to happen. So I'll go back and take a look at the JCL here, and I'll just submit it to run again. And so now I've created another generation, and I'll submit it again. And I've created another generation. So now when I look at this, what I will see when I go out here is I'll see all 3 generations have been created now. So here I've used the same base name, which means that I can run this job as often as I like, and I will always create a unique data set name, but I will be able to retain up to 3 versions of this data set. And so in this case, you can see we have generation 1, 2, and 3. Now observe that when I go to run this one more time, what's going to happen now is that since we have a limit of 3, then when I go out here and I take a look at this particular data set, notice now that generation 1 has been deleted and I have a generation 2, 3, and 4. This is essentially all there is to it as far as generation data sets go. If I refer to generation 0, then I'm going to pick up the one that has the 4 in it, since that's the most current one. Generation -1 would be generation 3. Generation -2 would be generation 2. That's as far back as I can go with a limit of 3. Similarly, if I create 1 and 2 new generations, that I'm going to use a +1 or a +2 to indicate that I want to create new generations. And as we said, based on the limit, the oldest ones will be deleted once we've exceeded that limit. But this is the role of generation data sets. They are very commonly used, especially for things like taking backups or keeping different versions of data, so that we don't have to keep creating new data set names in our JCL, but instead we can use a common name, have the system generate a unique low-level qualifier, and that way we can simply reference the old data set versus the new one, using the relative generation numbers and maintain consistency in our JCL so that we don't constantly have to invent new names. And that's one of the primary benefits that we derive out of generation datasets. This pretty well concludes most of what we need to discuss regarding JCL. The next two modules will relate to the utility programs, both in terms of the general IBM utilities and then a few specific ones like the IEFBR14, the IDCAMS, which is the VSAM utility, and then sorting.